So that's simplifying complex number questions, fractions that involve fractions. So you trying to simplify this will involve fractions, and you notice the first is you notice in here is the denominator, the conjugates. So therefore you would find the common denominator for both. So that's in fractions. You know that you cannot add fractions unless they have common denominator, and they made it simpler by having the conjugate in the denominator for both denominators. Therefore it's easier. That's why it's a merit. So it's ak plus I times 1 plus I plus, so you're multiplying this over 1 minus I times 1 plus I. And now you would start expanding. So writing this step is quite important because that will make sure that you do not expand, you miss anything in your expanding. Because I times I is negative, so therefore -1, that's why we have negative k, and then plus 2k minus 2ki. And then the bottom, we know when we multiply by the conjugate is the square for the first term plus the square for the second term, which is again 1 because we only have I, so we've got 2. And now collecting like terms, so the denominator is 2. Now we collect like terms, so you've got this k with that negative k will disappear. So you've got positive 2ki and positive 2ki, and we've got negative 2ki, so that will cancel out. So only left is 2k. This with this will cancel, and that's why the answer is k. So another complex number question is a merit level, and you can see it's involve fractions. So this one is a proof, but because it's involved fractions, well, we treat it the same way. So the first thing, you will substitute the complex numbers given. Expand because we're multiplying by the conjugate, so the real term square minus the imaginary term square, and then here by expanding a plus a is 2a, and then those will cancel out because I've got negative and positive in here because there's a plus between them. So because it's, you can see there's no I, so no imaginary term, therefore it's proven. So that's another complex number question, and also involving fractions, but this time is asking for arg, but approaching the question will be the same. So I will first substitute, and then because it's a fraction and because the denominator is a complex number, so I would multiply by the conjugate of the denominator, and then now expand. I will have a negative pq minus pqi minus pqi, and then positive pq over is the complex number multiplied by its conjugate, so it would be q square plus q square. Okay, the imaginary term square plus the real term square. Simplify, thus will simplify, so I'll end up with negative 2 pqi over 2q square. Now cancel out, and then 1q with that one, so I'll end up with negative pi over q. So negative pi over q, that means it's an imaginary component, and it's a negative imaginary component, so definitely would be on the negative. So the arc for that either you will take it as clockwise, so it will be a negative. So the arg for u over v, you either do anti-clockwise, clockwise, so it's negative, so negative pi over 2, which is 90, or you would say the arg for u over v clockwise will be 3, so it's clockwise from the real to the imaginary, so it will be 270 degrees, so therefore will be 3 pi over 2. So one of those two will give me the answer.